SpaceX successfully launched its 28th rocket of the year on December 9, ferrying an X-ray observatory into space for NASA. On Thursday morning, a used Falcon 9 rocket blasted off from Pad 39A at NASA's Kennedy Space Center in Florida, carrying the imaging X-ray polarimetry explorer. Following a successful liftoff, the rocket's first stage landed on one of the company's three massive drone ships, which serve as floating landing pads. The mission marked the fifth successful flight for this particular booster. The rocket's upper stage performed as expected, with spacecraft separation taking place 33 minutes into the flight. Approximately 1 minute later, the spacecraft unfurled its solar arrays and entered its orbit around Earth's equator at an altitude of roughly 600 kilometers. About 40 minutes after launch, mission operators received the first spacecraft telemetry data. The satellite, which is approximately the size of a refrigerator, is a $214 million mission. At an estimated mass of 325 kilograms, it is the smallest dedicated payload to fly on a SpaceX Falcon 9 rocket. The IXP Observatory, a joint effort with the Italian Space Agency, equipped with three identical telescopes, is NASA's first mission dedicated to measuring the polarization of X-rays from the most extreme and mysterious objects in the universe, such as supernova remnants, supermassive black holes, and dozens of other high-energy objects. The high-energy X-ray radiation from these objects' surrounding environment can be polarized, vibrating in a particular direction. Studying the polarization of X-rays reveals the physics of these objects and can provide insights into the high-temperature environments where they are created. The spacecraft's first light operations are scheduled to begin in January, and its first target will be the Crab Nebula, which is the remnant of a dead star. On December 11, Blue Origin successfully launched its third crew of passengers to space and back on the company's New Shepard rocket. The crew included Michael Strahan, host of the American TV show Good Morning America. Laura Shepard Churchley, the eldest daughter of Alan Shepard, the first American in space and the namesake for the New Shepard rocket. Also included in the crew were Evan Dick, an engineer and investor, as well as Lane Bess, the founder of Bess Ventures and Advisory. Bess brought along his son, Cameron Bess, making them the first father and child duo to ride to space together. The final crew member was Dylan Taylor, the CEO of Voyager Space, an active investor in the space industry. While Strahan and Churchley were honored guests, other four were all paying customers for the flight. The New Shepard NS-19 mission lifted off just after 10 a.m. Eastern Time on Saturday morning from Blue Origin's launch facility in Van Horn, Texas. Riding inside a crew capsule on top of the New Shepard rocket, the six-person crew climbed to an altitude of 107 kilometers, or more than 100 kilometers above the Earth, which is considered to be above the boundary to space. After experiencing a few minutes of weightlessness, the capsule carrying the crew touched down on the Texas desert floor, while the New Shepard successfully landed upright on a landing pad. The entire flight lasted just over 10 minutes from liftoff to touchdown. This is the first time a group of 6 people has flown together on the vehicle. Before Saturday's launch, Blue Origin had only flown crews of 4 to space on New Shepard. After touchdown, all 6 of the passengers on the flight received their commercial astronaut wings from the Federal Aviation Administration, which has historically given the small pins to people who fly above 80 kilometers. However, this week the FAA announced it would be ending this practice by the end of the year, citing the advent of the commercial space tourism era. The NS-19 mission brings Blue Origin to 14 people launched to space in 2021, a year that has seen a flurry of private human spaceflight activity. A Soyuz MS-20 spacecraft carrying 2 Japanese private astronauts and a Roscosmos cosmonaut arrived at the International Space Station on Wednesday, December 8. The trio left Earth the same day just 6 hours earlier, launching atop a Soyuz rocket from Baikonur Cosmodrome in Kazakhstan. One of the tourists on board was Yusaku Mizawa, a Japanese billionaire who announced his intention a few years back to fly around the moon on SpaceX's Starship rocket. He plans to flight 10 to 12 people on SpaceX's Starship rocket for a multi-day trip that would reach lunar orbit, with Mizawa saying he will pay for the entire journey. The mission, dubbed Dear Moon, is currently scheduled for 2023. Mizawa's crewmates include Russian cosmonaut Alexander Misurkin and Japanese tourist Yozo Hirano, who is Mizawa's producer and manager. The crew docked with the Poisk module of the Russian segment of the space station at 1:40 p.m. GMT, and the hatch of the Soyuz MS-20 capsule opened at 4:11 p.m., showing Russian cosmonaut Alexander Misurkin entering the station, followed by Mizawa and Hirano. Mizawa will share his experience on the space station, as filmed by Hirano, on his YouTube channel. In addition to filming Mizawa's activities on the station, Hirano will conduct biomedical research for the Translational Research Institute for Space Health. He will collect data on the effects of the spaceflight environment on the human body. Ms. Erkin will serve as Misawa's and Hirono's guide during the mission and will become the first space-based correspondent for the Russian news agency TASS. Under an agreement with Roscosmos, Ms. Erkin will establish a TASS news office on the station and file daily reports about the activities of the crew. Misawa and Hirono will primarily remain on the Russian segment of the station. They will briefly visit the cupola in the US segment for filming, as well as have some limited access to laptops for internet access. The trio is scheduled to come back down to Earth on Sunday, December 19th. A United Launch Alliance Atlas V rocket launched the Space Test Program 3 mission for the U.S. Space Force on December 7, lifting off from Space Launch Complex 41 at Cape Canaveral Space Force Station in Florida. The $1.1 billion STP-3 mission carried classified national security payloads and a NASA mission to demonstrate in-space laser communications. The primary payload, STP-SAT-6, hosted the National Nuclear Security Administration's Space and Atmospheric Burst Reporting System 3, a sensor designed to detect nuclear explosions. The secondary payload was the Long-Duration Propulsive ESPA, a small satellite adapter ring designed to deploy 6 military experiments focused on space weather and situational awareness. About 6 hours after liftoff, the 2 satellites on board were deposited into a geosynchronous orbit, sailing roughly 36,000 kilometers over the equator. STP-SAT-6 also carried NASA's Laser Communication Relay demonstration payload that will be used to test laser communication in space between Earth and the geostationary orbit. Currently, most NASA missions use radio frequency communications to send data to and from spacecraft. However, as space missions generate and collect more data, the need for enhanced communications capabilities becomes paramount. Optical communications are one of these enhancements and will provide significant benefits for missions, including bandwidth increases of 10 to 100 times more than radio frequency systems. Once the satellite is in the intended orbit, engineers located at LCRD's Mission Operations Center in New Mexico will start the activation process by turning the payload on and get it ready to start transmitting test data over infrared lasers. Once operational, missions in space will send their data to LCRD, which will then relay the data down to designated ground stations on Earth. One of LCRD's first operational users will be the integrated LCRD Low Earth Orbit User Modem and Amplifier Terminal, a payload that will be hosted on the International Space Station. NASA's plucky Ingenuity helicopter has successfully completed its 17th Mars flight on December 5, but something unusual happened near the end of the journey. Everything went as planned during the helicopter's 187 meters traverse to the northeast. However, during the final descent phase of the flight, the communications link between Ingenuity and the Perseverance Mars rover was disrupted. Approximately 15 minutes later, Perseverance received several packets of additional Ingenuity telemetry, indicating that the flight electronics and battery were healthy. The Ingenuity team is looking into the communications issue and said it's likely due to a challenging radio configuration between Perseverance and Ingenuity during landing. A combination of factors might have contributed to the problem, including the rover's orientation in relation to Ingenuity and a hill that may have disrupted the radio signal at the end of the flight. The rotorcraft's 17th flight lasted 117 seconds, and the data it's transferred to the rover so far looks good for it having landed in a safe, upright position. The Ingenuity team is currently recovering the missing data to perform a final health assessment of the helicopter. If all is well, Ingenuity could fly again within a couple of weeks. Now, let's discuss some of the major Starship updates from the past week. Starship 20 and Booster 4 have been sitting idle at the launch site for the past week with no ground test activities. Meanwhile, on Monday, December 6, at the Wall Street Journal's CEO Summit, SpaceX CEO Elon Musk spoke a few words about the Starship program. He said that Starship is a very hard project that consumes more of his mental energy than almost anything else.
Man, Starship is a hard project. There has never been a fully reusable orbital launch vehicle. This is the holy grail of space technology. This absorbs more of my mental energy than probably any other single thing. But it is so preposterously difficult that there are times where I wonder whether we can actually do this.
When the interviewer asked Musk why Starship is a hard project, he briefly explained the main reason why it has been difficult to develop the two-stage launch system.
We live on a planet where the gravity is actually very strong. We actually live on the densest planet in the solar system. Our atmosphere is very thick. And what this comes down to is that a typical orbital rocket might be able to put about 2% of its liftoff mass into orbit. And then this is with smart people trying hard, maybe 2.5%. Then, and no rocket, to the best of my knowledge, has ever gotten above 4% of its liftoff mass to orbit. Incredibly efficient engines, incredibly efficient structure. You do need scale because there are some efficiencies of scale. That's why part of why Starship is so gigantic. Because, for example, the brain of the rocket really weighs about the same if it's a small rocket or a big rocket. So with a big rocket, you get to have the avionics be basically round down to 0% or be inconsequential in the mass of the vehicle. Then you need to make an incredibly light heat shield. And just there's so many things that need to be done to have both the booster and the upper stage or ship be reusable. Like many super smart people have tried to do this before and no one has succeeded. And most of the time they've just given up partway through. But if full and rapid reusability can be achieved, it reduces the cost of access to orbit by a factor of 100 or more.
During the summit, he mentioned that he is overdue for doing a Starship update, and later on Twitter he mentioned that it is about to happen this month. Since Starship's predecessor was first revealed in September 2016, Musk has only given 3 official Starship presentations. He has not provided an explicit Starship update since 2019, and SpaceX has made truly incredible progress in the last 2 years, completing a new prototype every month and flying one of those prototypes every 3 to 4 months. In short, Musk could shed a great deal of light on a near limitless number of activities and plans in the next Starship update presentation. As works at Starbase progresses toward the first orbital test flight of Starship, the U.S. Federal Communications Commission granted SpaceX a license to communicate with Starship via ground-based antennas to receive data during the test flight. According to the FCC filing, SpaceX targets to conduct the orbital flight before March 1, 2022. However, the company is still pending regulatory approval from the U.S. Federal Aviation Administration that is currently performing an environmental review of the Starbase launch site to ensure safe spaceflight operations. SpaceX will be able to apply for an FAA launch license once the environmental assessment is complete. The FAA had previously said that it has a target date of December 31 to conclude the environmental assessment process. Now, let us return to the updates from the Starbase. On Wednesday, December 8, Super Heavy Booster 5, the second orbital-class Super Heavy prototype, and perhaps the first to be caught with the booster catching arm, was taken out of the high bay and moved to a display stand near the build site. This could be to free up the space inside the high bay to stack Starship 21. Ship 21 is currently standing inside the mid-bay alongside its successor, Ship 22. Ship 21's tank section is fully stacked, and Ship 22's tank section is close to 2/3 complete. Works on Ship 22's nose assembly is in progress, while Ship 21's nose cone with the heat shield attached is ready for stacking. The booster quick disconnect mechanism installed over the orbital launch mount received its protective hood last week. Later on, SpaceX engineers conducted a movement check by sliding the hood's main door open and moving the QD arm forward. The QD shield will protect the QD arm and its sensitive components from the thousands-degree plume created by Raptor engines during liftoff. The Super Heavy Test Tank Booster 2.1, which underwent a series of pressure tests about 2 weeks ago, returned to the build site on December 12, ending its test campaign. As spotted by Eric Ralph, senior spaceflight reporter at Teslarati, we have some strong evidence that the air separation unit near the build site is actively producing some of the fluids, presumably liquid nitrogen, that is being used to fill the orbital tank farm. Moreover, a truck was recently spotted leaving the propellant production plant carrying liquid nitrogen to the launch site. With this, we have covered all the major updates from last week. Please share your thoughts on the latest science news and Starship updates in the comments section. Also, do not forget to subscribe to the channel for more weekly updates. And as always, thanks for watching.